Welcome back to another episode of Rossie Teaches. Today's misconception is going to be on heterochromatin versus euchromatin. Let's get straight into it. So first off, we're going to start with heterochromatin. Now, when we see heterochromatin, or when we think of heterochromatin, I want us to think of the first letter in heterochromatin, which is this H. And I want us to familiarize this H with H being as in highly condensed and H as being in highly compact. And that's because the DNA strand is closed. And because it's closed, it's highly compact, this doesn't allow for the DNA transcription factors to bind to the DNA to start transcription, which as a result ends in inactive transcription. Okay? So let's go over that one more time. So H for heterochromatin, H for highly condensed, H for highly compact. When it's highly condensed and highly compact, the DNA strand is closed. When the DNA strand is closed, the DNA transcription factors are not able to bind to the DNA strand, leading to inactive transcription, okay? Let's move on to euchromatin. Same thing as before. When we think of euchromatin or when we see euchromatin on our exams or quizzes, let's think of that first letter, which is E, okay? And I want us to familiarize the letter E with expressive. And it's expressive because the DNA strand is now open in euchromatin. And since it's open, we see that the DNA transcription factors are able to bind to that DNA, and as a result, have active transcription. Okay, so let's go over that. E for expressive. Since it's expressive, the DNA strand is open. When the DNA strand is open, we have the DNA transcription factors that can bind. And since they are able to bind to the DNA strand, we have active transcription. Now, Rossies, I want to go over one more thing, which is the location of euchromatin and heterochromatin. Now, this can be very confusing when it comes to exams, quizzes, even practice problems. So I want us to be able to master this, okay? So you may have even come across questions that ask the location of hetero and euchromatin as well. So let's look at the diagram on the bottom left here. I've drawn a cell and the nucleus. The heterochromatin and euchromatin are found in the nucleus of a cell. So let's zoom in into the cell. So here we are in the nucleus. I have labeled in red with the E and in blue with the H. E for euchromatin, H for heterochromatin. Let's start with euchromatin first. How I like to remember where euchromatin is located is E is for euchromatin, E for the inside. Euchromatin is found in the center of the nucleus. So E for the inside, E for euchromatin for the center of the nucleus. Now, for heterochromatin, H for heterochromatin or H for outside. Okay, outside, just a small little mnemonic for us to remember. But once we're able to remember one, we should be able to get the other. So just one more time, H for heterochromatin, H for the outside, so the peripheral or the periphery of the nucleus. E for euchromatin, E for the inside, and the inside, the center of the nucleus. Okay? So this is just what I do to help me remember the difference between the locations of eu and heterochromatin. And that's all for today. Thank you so much, Rossies. And as always, good luck and have a good one.